In this episode, we look at browser-based attacks and why the web browser has become one of the most important attack surfaces in modern cybersecurity. A browser is no longer just a tool for reading websites. It is where you open email, manage documents, use business applications, join meetings, access cloud dashboards, approve workflows, store passwords, and maintain signed-in sessions across many services. That makes the browser valuable to attackers. If an attacker can influence what runs in the browser, what the browser stores, what extensions can see, or what session information can be stolen, the attack may reach far beyond one web page. Browser-based attacks can involve malicious extensions, harmful JavaScript, stolen cookies, abused password managers, or hijacked session tokens. The browser sits close to identity, data, and daily work, so learning how it can be attacked helps you understand a major part of today's security landscape. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.Me in the Bare Metal Study Guide series. A browser is an attack surface because it constantly receives and processes outside content. Every website you visit sends code, images, forms, scripts, cookies, and other data for the browser to handle. Most of that activity is normal and safe enough when the website is trustworthy and the browser is updated. The risk appears when a website is malicious, when a legitimate website is compromised, when an extension behaves badly, or when a user is tricked into entering information on a fake page. The browser has to make quick decisions about what to display, what to run, what to remember, and what to send back to a site. Attackers look for ways to abuse those decisions. They may try to steal credentials, capture session data, redirect users, display fake content, or run code that performs actions the user never intended. The attack may feel like ordinary browsing until the consequences appear later. JavaScript is one of the main technologies that makes modern websites interactive. It helps pages respond to clicks, update information, validate forms, display menus, and communicate with services behind the scenes. JavaScript itself is not bad. The problem is that code running in a browser can become dangerous if it comes from a malicious source, is inserted into a trusted site, or is allowed to handle sensitive information unsafely. Attackers may use JavaScript to redirect you to fake login pages, capture data typed into forms, display deceptive prompts, or interact with a page in ways that support fraud. A common web attack concept is cross-site scripting, XSS, where malicious script runs in the context of a website that a user trusts. You do not need to write scripts to understand the risk. If the browser runs attacker-controlled code in a trusted place, trust can be abused. Cookies are small pieces of data that websites ask the browser to store and send back later. They can help keep you signed in, remember preferences, track a shopping cart, or support normal application behavior. Like many browser features, cookies are useful, but they can become valuable to attackers because they may represent trust. If a cookie helps prove that a user already signed in, stealing that cookie may help an attacker act as that user for a time. Not every cookie is equally sensitive, and websites can apply protections that make cookies harder to steal or misuse. Still, the main idea is clear. A password is not the only thing that proves identity in web applications. After sign-in, the browser and the site often rely on stored session information. If attackers can take or abuse that information, they may bypass parts of the normal login process. Session tokens are closely related to this idea. A session token is a value that helps a web application recognize an already authenticated session. After you sign in, the application does not usually ask for your password on every click. Instead, it uses session information to remember that your browser is already approved. This makes web applications usable, but it also creates a target. If an attacker steals a valid session token, they may be able to access the application as though they were the signed-in user until the session expires or is revoked. This is often called session hijacking or session theft. The attacker may not need to know the password if the session token is still accepted. Multi-factor authentication, MFA, is still valuable, but session theft can reduce its protection if the attacker steals proof that authentication already happened. That is why protecting sessions matters so much. Session theft can happen in several ways, and you should think about the pattern rather than memorizing every possible method. A malicious script might try to access session-related data if protections are weak. A compromised device might let malware steal browser data. A fake website might trick a user into entering credentials and then capture the resulting session through a more advanced phishing technique. An attacker with access to an unsecured network path might try to observe traffic if protections are missing or misused, although strong encryption makes that harder. A malicious browser extension might read or manipulate pages the user visits. In each case, the attacker is trying to obtain something that lets them act with the user's trust. The browser becomes the bridge between identity and application access. When that bridge is attacked, the result may look like a normal signed-in user doing abnormal things. Password managers are another browser-related topic because they help people handle many passwords without memorizing or reusing them. A good password manager can improve security by creating strong, unique passwords, storing them securely, and reducing the temptation to reuse the same password everywhere. Many people use browser-integrated password managers or password manager extensions because they are convenient. Attackers care about them because they sit close to credentials. The main risk is not that password managers are bad. In many cases, they are much safer than weak repeated passwords. The risk comes from compromise of the device, fake login pages that trick the user, malicious extensions that observe form fields, weak account recovery, or poor protection of the password manager account itself. A password manager should be protected carefully because it can become a concentrated point of access to many services. A password manager can also help defend against some phishing if it only fills credentials on the correct website. For example, if a fake site looks like a real service but has a different domain, the password manager may not offer to fill the saved password. That warning can be useful if you notice it. But attackers may still try to fool users with lookalike domains, compromised legitimate pages, or prompts that ask the user to copy and paste information manually. Some attacks also target the person's trust rather than the password manager's rules. A page may claim that automatic filling failed and ask the user to type the password directly. It may ask for a one-time code, an approval, or other information. The safer habit is to treat unexpected sign-in prompts carefully, especially when they come from links in messages, documents, or chats. Convenience should not replace verification. Browser extensions are small add-ons that change or expand what the browser can do. They may block ads, manage passwords, translate pages, capture screenshots, check grammar, organize tabs, support meetings, or connect to business tools. Extensions can be helpful, but they can also be risky because many require permission to read or change data on websites. A malicious extension may observe browsing activity, capture information typed into pages, inject ads, redirect traffic, steal tokens, or change what the user sees. A once trustworthy extension can also become risky if it is sold to a new owner, compromised, or updated with harmful behavior. The danger is access. An extension that can read every page you visit may sit in a powerful position. It may see webmail, customer portals, administrative consoles, cloud tools, and internal applications. That makes extension control a serious security concern. Malicious add-ons often succeed because they look useful or harmless. A user may install an extension to perform a small task and quickly approve permissions without reading them closely. The extension may have a professional icon, positive-looking reviews, or a name that sounds like a normal productivity tool. In an organization, one employee installing a risky extension can create exposure if that browser has access to sensitive business systems. Security teams may manage which extensions are allowed, block unapproved add-ons, review permissions, and monitor for known risky extensions. For you as a new learner, the main idea is that browser extensions are software with access. They are not just decorations on the browser. If they can read pages, modify content, or interact with sessions, they can affect security. A small convenience tool can become a large risk when it sits beside sensitive work. Credential exposure is one of the most common goals of browser-based attacks. Attackers want usernames, passwords, one-time codes, recovery information, session tokens, or anything else that helps them access accounts. A fake login page may look nearly identical to the real one. A malicious script may capture what is typed into a form. A browser extension may observe fields across sites. A compromised endpoint may extract saved credentials or browser data. A phishing message may bring the user to the browser at exactly the moment the attacker wants. Once credentials are exposed, the attacker may try them on the original service, other services, or remote access systems. If passwords are reused, one stolen password can unlock several accounts. This is why unique passwords, MFA, password managers, conditional access, monitoring, and user reporting all work together. No single control solves every browser-based credential risk. The browser also connects to cloud services, which makes session and credential theft especially serious. Many organizations rely on software as a service, SaaS, applications for email, files, finance, human resources, customer management, development, and administration. These tools are often reached through the browser, and access may be tied to single sign-on, SSO. SSO lets a user sign in once and reach multiple connected services without separately entering passwords for each one. That improves usability and can improve control, but it also raises the value of a stolen session or compromised identity. If an attacker gains access to one browser session tied to many services, the possible impact grows. They may read email, find files, create sharing links, approve applications, or search for more credentials. Browser security and identity security are deeply connected because the browser is often where identity becomes action. Defending against browser-based attacks requires layered habits and layered controls. Keeping browsers updated matters because updates fix known weaknesses. Limiting extensions reduces the chance that a risky add-on can see sensitive activity. Strong password managers help create unique passwords, while MFA adds another barrier against stolen credentials. Session protections can reduce how long tokens remain useful and can detect suspicious sign-in behavior. Web filtering and safe browsing features may block known malicious sites. Endpoint protection can detect malware that tries to steal browser data. Organizations may also use policies that prevent unsafe extension installation, restrict copying sensitive data, and require re-authentication for high-risk actions. For a user, careful attention still matters. Unexpected sign-in prompts, unusual browser pop-ups, suspicious extension requests, and links from messages should slow you down before you enter credentials or approve access. There are also common misunderstandings to avoid. One misunderstanding is that a secure website appearance always means the page is safe. A site can use encryption and still be controlled by an attacker. Another misunderstanding is that MFA makes session theft impossible. MFA helps a great deal, but if an attacker steals a session after authentication, the situation changes. A third misunderstanding is that browser extensions are automatically safe because they come from a public store. Stores may review extensions, but risky or malicious ones can still appear, and legitimate extensions can change over time. Another mistake is saving credentials carelessly on shared or unmanaged devices. The browser should be treated as a sensitive workspace, not a casual tool with no security impact. If the browser can reach important accounts, then attacks against the browser can become attacks against the organization. As you continue with Security Plus version 8 and SY0801, remember that browser-based attacks matter because the browser is where communication, identity, applications, and data meet. JavaScript can make websites useful, but attacker-controlled script can abuse trust. Cookies and session tokens make signed-in experiences work, but stolen session data can let an attacker act as a user. Password managers can improve security, but they must be protected because they sit close to credentials. Extensions can add useful features, but malicious or over-permissioned add-ons can see and change too much. The browser is now a major attack surface because so much work happens inside it. A strong security mindset treats browser activity as part of the organization's real environment. When you protect the browser, you are also protecting accounts, sessions, data, cloud applications, and the decisions people make every day.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.